Have you ever stopped to think about time? It flows around us, through us, and carries us forward from one moment to the next. We measure it with clocks and calendars, marking its passing with birthdays and anniversaries. It feels as real and as constant as a great invisible river. We are all passengers on this river, drifting steadily from the past, through the present, and into the future. You can remember yesterday, but you cannot visit it. You can plan for tomorrow, but you cannot live it until it arrives. This one-way journey is something we all experience without a second thought. It is the fundamental rhythm of our existence, the background music to our lives. This forward march of time is so deeply ingrained in our experience that we rarely question it. A broken egg will never spontaneously reassemble itself into a whole one. A splash in a pond will never gather its ripples back to a single point. Smoke from a fire never unbillows and funnels back into the wood. These events are irreversible. They happen in a specific order, and that order is always the same. This unwavering directionality, this strict sequence of cause and effect, is what scientists call the arrow of time. It points resolutely from what was to what will be, and it never, ever seems to turn back. We all have an intuitive grasp of time's arrow. It is the reason we make plans, the reason we learn from our mistakes, and the reason we cherish fleeting moments. Think about stirring milk into your coffee. The two liquids mix together, creating a uniform, light brown beverage. You would be utterly astonished if you saw the milk and coffee spontaneously separate, with the white swirls neatly extracting themselves from the dark liquid. This sense of what is possible and what is impossible is built upon our lifelong observation of the arrow of time. When physicists write down the fundamental laws that govern the universe, they find something truly peculiar. Most of these laws are time-symmetric. This means that the equations work just as well whether time is running forwards or backwards. For example, the laws of gravity that describe a planet orbiting a star do not care about the direction of time. If you were to watch a video of a planet in its orbit and then watch it in reverse, you would not be able to tell which was the correct direction. Let's begin our exploration with a simple breakfast scene, a universal experience that holds a profound scientific truth. Imagine you are in your kitchen on a bright morning. You take a fresh, perfectly formed egg from its carton. Its smooth oval shell is a marvel of natural engineering, a container of potential life and nourishment. With a gentle tap, you crack it against the side of a bowl. The shell gives way, and the clear albumin and golden yolk spill out, ready to be whisked into a delicious scramble. Let us move from the kitchen to the playground, to another common experience that illustrates time's unyielding forward march. Think back to your childhood. You are running, full of energy, when your foot catches on an unseen obstacle. You tumble, and your knee scrapes against the rough ground. There is a moment of sharp pain, followed by the sight of broken skin and a trickle of blood. This is the cause. The effect follows a clear and predictable sequence. The wound will slowly stop bleeding, a scab will form to protect the new skin growing underneath, and over days or weeks it will heal, perhaps leaving a faint scar as a permanent record of the event. Now let's consider an example that involves sound and information. Imagine you are standing in a vast empty cathedral or a deep canyon. You shout a single word, hello. The sound travels outwards from your mouth, a pressurized wave of air moving through space. A moment later, you hear your voice return to you as an echo, then another, fainter one, and another, as the sound bounces off the distant walls. Each successive echo is weaker and more distorted than the last, until eventually the sound fades away completely. Let's scale up our examples from the kitchen and the playground to the cosmos itself. Think of the universe as following a grand recipe from a cosmic cookbook. The story begins with the Big Bang, an initial state of incredible heat, density, and crucially, very low entropy. The early universe was remarkably uniform and simple. All the matter and energy that would ever exist were packed into an infinitesimally small point. Now this is where our story takes a very strange turn. We have just established with eggs and echoes and scraped knees that time in our world is a one-way street. Events happen in a fixed order, and reversing that order is simply not something we ever see. It feels like a fundamental, unbreakable rule of reality. Yet, when physicists peer into the rulebook of the universe, the very laws that govern everything from the smallest atom to the largest galaxy, They find something utterly baffling. So, how do we reconcile these two conflicting realities? On one side, we have the time-symmetric laws of physics, a world of perfect reversibility. On the other, we have our macroscopic experience, where time's arrow is an undeniable, ever-present force. It feels like the universe is playing a clever trick on us. The rules at the microscopic level seem to promise a world where time's flow is not absolute, yet the world we actually live in is governed by the strict, one-way progression from past to future. Let's try a thought experiment to truly grasp what a time-symmetric world would feel like. Imagine a universe where the statistical reality we just discussed did not apply. A universe where events could happen just as easily forwards as they could backwards. What would this reality look like? Imagine your bedroom. When you have just tidied it, everything is in its proper place. Your books are on the shelf, your clothes are in the wardrobe, and the floor is clear. This is a state of low entropy. It is highly ordered. Now, what happens over the course of a week? A book gets left on the bed, a stray sock appears on the floor, and a cup is left on the desk. The room drifts towards a state of higher entropy, a state of disorder. The second law of thermodynamics is not like other laws of physics. It is not a law of absolute certainty, but a law of overwhelming probability. It does not say that it is impossible for your messy room to spontaneously tidy itself. It just says that it is astronomically unlikely. If the universe is always moving towards a state of greater disorder, then it must have started in a state of very high order. For an arrow to be fired, it needs a starting point. For the arrow of time to exist, the universe must have begun in a special low entropy condition. And indeed, that is exactly what our cosmological models tell us. So let us put all the pieces together. The arrow of time that we experience is not a fundamental property of the laws of physics themselves, which are largely time-symmetric. Instead, it emerges from a combination of two key factors. The first is the second law of thermodynamics, the statistical rule that isolated systems will always move towards a state of higher entropy or greater disorder. We have established that the arrow of time is driven by the universe's journey from a highly ordered past to a disordered future. This forces us to confront the ultimate edge of time, the very beginning. What happened at the Big Bang, that initial moment 13.8 billion years ago? If the Big Bang is the edge of time in the past, then black holes represent an edge of time in the future. A black hole is formed when a massive star collapses under its own gravity, creating a region of space-time so warped that nothing, not even light, can escape. Having explored the beginning of time and its distortion in black holes, we now turn to the final cosmic edge, the ultimate future of the universe itself. If the arrow of time is driven by the increase of entropy, what happens when entropy reaches its maximum? We have built a strong case for the arrow of time based on entropy and the unique starting conditions of our universe. This thermodynamic arrow driven by the second law seems to explain everything from a scrambling egg to the cosmic expansion. We have journeyed to the edges of the cosmos and into the quantum realm, but perhaps the strangest possibility of all is the most fundamental. What if the arrow of time, and even time itself, is not a fundamental feature of reality at all? What if it is an illusion, an emergent property that arises from a deeper timeless reality? Our journey through the puzzle of time's arrow has taken us from the familiar comfort of a morning coffee to the mind-bending edges of the cosmos and the strange depths of the quantum world. We began with a simple observation. A broken egg does not reassemble itself. This everyday truth led us down a rabbit hole into the heart of modern physics, revealing a profound paradox. The fundamental laws that govern individual particles are mostly time-symmetric, working just as well forwards as they do backwards. Yet the macroscopic world we inhabit marches forward with an unwavering, irreversible rhythm. This discrepancy is the central mystery we set out to explore, a grand deception played by the universe. The key to resolving this paradox, we discovered, lies in the powerful concept of entropy and the second law of thermodynamics. Time's arrow is not a feature of the underlying physical laws, but an emergent property of statistics and probability. The universe moves from order to disorder simply because there are vastly more ways to be disordered. This statistical arrow, however, required a crucial starting condition. the incredibly low entropy state of the Big Bang. The universe began its life in a state of remarkable order, and its entire history has been the story of that order slowly and inexorably unwinding, giving time its forward direction. Understanding this matters far beyond the realm of theoretical physics. It shapes our entire perception of reality. It explains why we can remember the past but not the future, why cause always precedes effect, and why we age but never grow younger. The arrow of time is the very framework upon which our lives are built, the narrative thread that allows for memory, learning, and planning. It is the reason we can make sense of the world and our place within it. The relentless march from an ordered past towards a disordered future is what allows for the temporary creation of complex structures like stars, planets, and ultimately, life itself. So, the next time you watch steam rise from a hot drink, see ripples spread across a pond, or simply reflect on a memory, you are witnessing the profound legacy of the Big Bang. You are seeing the second law of thermodynamics play out in real time. You are experiencing the statistical certainty that governs a universe of trillions upon trillions of particles. The arrow of time is not just an abstract concept, it is woven into every moment of our existence. It is the silent, invisible current that gives our universe its history, its future, and its meaning, reminding us that we are all passengers on an extraordinary cosmic journey.